Hello everyone, good morning students. Today I am coming to take the topic that is current electricity. I choose this topic students because it is not only important for your 9th standard but this topic again continue in your 10th standard also. That's why we take the topic electricity. So we will continue. Current electricity. Electricity becomes most important part in our daily life, as you know. In our household appliances also, fan, electric fan, refrigerator, washing machine, so many appliances we have which operates only due to electricity. If suppose any time that power is off or no supply of electricity, then we have the solution. Many of the big hospitals, schools, they have the options for this. They arrange the alternative for this. If the power supply is cut off or electricity is not available, then we use the generator. This means in market generator machine is also available. Students, not only human being but electricity becomes an important part for animals also. You must have learned in your science too that one fish is there. I think that name of fish is eel. It is a name of fish. She also produces this electric current because for self-defense purpose. So not only for living being but also for animals also this electricity becomes utmost very important. Okay, so how to learn this electricity? Actually, electricity word comes from the electrons. You all know about the atoms. In your 7th standard, 8th standard, you all learn about the atoms. What are atoms? In short, we will take a review of this topic. What are atoms? Atoms are the smallest particle which we cannot again redivide. It contains fundamental particles that are protons and that are electrons. You all know that protons contains the positive charge and electron contains the negative charge. So the flow of this negative charge particle, that is the flow of this electron, is called as electricity. So from this electron pass out through the conducting wire. We need a wire, we need a conductor to flow the current, okay, to flow the electrons through the wire. Before going this topic, before move further, now we will discuss about the potential difference. I have drawn here a diagram which is given in your book also. This diagram show the direction of flow as well as we will discuss about the what is potential difference. Okay student, look at this diagram. In this diagram we have taken two plastic bottle. In first, that is in figure number A, we take two plastic bottle, we fill up a water in that plastic bottle. Both the bottles, they are attached with a pipe, small pipe, and again I put a clamp over here. In this diagram there is no clamp. This means if we remove the clamp from these two bottles, what will happen? In first case, the level of this water, it transfer from higher level to lower level. So first higher level to lower level. So this become one terminal. In second bottle, up to what this flow of water takes place, कब तक ये flow of water चालू रहेगा? So this flow of water continues unless and until the level of water in both the bottle it became the same. As the level became the same in both the bottle, the flow of water stops. This means the direction of flow always from upper position to lower position. Similarly, we have two terminals, that is positive terminal and negative terminal. These two terminals are also called as high electric potential and low electric potential. Okay, both the terminals, that is positive terminal and negative terminal, both the terminals, they are attached with this conducting wire. What is the meaning? What is the meaning of conductivity? You all know that conductors and insulators. In your previous standard, you have learned about the conductors and insulators. What are conductors? Those substances, they can carry the electric current, or those having the low resistance, they are called as conductors. For example, you all know that copper, aluminium, silver, these are the good conductors of electricity. Similarly, insulators are those substances which cannot carry the electric current, means there is no flow of electron. For example, wood, plastic, etc. Okay, so here we have a conducting wire. We can say that this wire is made up of copper. Okay, conducting wire means it can carry the electric current, means negative terminal to positive terminal. So until and unless there are two terminals, until and unless the flow of electron become equal, until and unless the flow of electron becomes equal, means this negative charge travels toward the positive charge, and when the charge on both the terminal it become equal, then we can say that our potential difference becomes zero. When our potential difference becomes zero. In our first figure, here the level of water in both the bottle, when it become equal, the flow of water stops. The flow of water stops. Similarly, the flow of electron stop in this figure when the potential difference becomes zero, or when both the terminals they carry the equal electric charge or equal electric current. Okay, so this difference is called as potential difference. For this we have two terminals, one is positive terminal and another is negative terminal. As you all know that negative means electrons, so definitely that transfer of electron takes place from this terminal to this terminal. Okay, now next topic, what is the meaning of potential difference of a cell? What is the potential difference of a cell? You all have known what is cell. Okay, it is not the cell like that fundamental unit of life. It is a cell, or it is a battery which we use at our home in many of the electric appliances. So this cell actually it contains the chemicals. Actually this cell they contains the chemicals, and that chemical carry the charge. That chemicals carry the charge that are called as cell. So just like this diagram, cells also have two terminals. Cells also have two terminals. One terminal is called as positive terminal and another terminal is called as negative terminal. In our book, this cell is denoted as like this. One carries positive charge, another carries negative charge. It is also called as battery. Okay, I will give you one example. Just like I told you about the conductors. Okay, what is the meaning of conductor? Conductor means those substances which carry the electric current. It is given in 10th standard also. Those carrying the electric current, they are called as conductors. Now I told you that iron is a good conductor of electricity, as well as it is a good conductor of heat. So why don't we get electric shock when we touch the iron? Every day we come in contact with iron in every object, every material. For example, cycle, for example, two-wheeler, it is also made up of iron. So why don't we get the electric shock? So our answer is the electrons which carry the electricity, that electrons are in the free state. They are in the free state. They are called the free electrons. They are called the free electrons. For example, if we have the iron nail, so iron nail also contains the electrons, but at that time that electron is called a free electron. Okay, now let us draw one diagram from which we can understand. have a copper wire or iron nail. You can consider any of the example. Suppose I have a iron wire, I have a copper wire or iron nail, and this is in free state. It is not connected with any of the battery. So it also contains the electrons. It also contains the electrons. Okay, another example. Again, I have another piece of wire. It also contains the electrons. It also contains the electrons. Okay. See the difference between the two diagrams. In first diagram, the electrons move randomly here and there because they are called as free electrons. In another diagram, the electrons, they move in a proper order because we connect the wire with the cell. We connect the wire with the cell. One is positive terminal, another is negative terminal. So see the difference between the two diagrams. If electrons are in the free state, they will not charge any of the electric current. But if we attach that wire, that copper wire with this cell, this means it applies the current, it applies the charge, and these electrons, they move, they flow in a proper direction, that is from negative terminal to positive terminal. Okay, so this is the flow of electric current, and this is the answer for 10th class why we don't get shock if we touch the iron. Okay, because at that stage that iron contains the free electron. That's why though silver is a good conductor of electricity, copper is a good conductor of electricity, but simply by touching that metals we cannot get the electric shock because the electrons are present in the free state. Okay. Students, the transfer of electron takes place in a proper manner from atom to atom for any of the substance. Suppose this is a nucleus. Nucleus is the center of the atom. Okay, it contains proton, it contains electron, etc. Now, this proton carries a positive charge, and surrounding this, so many electrons are there. So how the transfer of electron takes place? Transfer of electron takes place from one atom to another atom, one atom to another atom. This is the way through which the transfer of electron takes place from one atom to another atom. Just like in 7th standard, you might have studied the transfer of heat also. At that time also I have explained you that how the transfer of heat takes place. If we hit something, if we hit any of the object, then first we hit this object. If we hit this object, then heat energy is supplied to this object, heat energy is supplied to this object. Similarly, at the end of all the objects, they get the heat energy. Just like that, electrons also moves from one atom to another atom. Okay. Now students, what is the meaning of electric current? If you want to write the electric current, we have to denote it with I, that is capital I. What is actually the electric current? Actually the electric current is the flow of charge through a conducting wire, and how much charge we apply during that time. For example, electric current means I. How much charge means Q, and how much time we are giving to apply that charge, that is T. I means current, I shows the current, Q shows the charge, how much charge we will apply for how much time. So the students, the unit of this current is ampere. The unit of this current is ampere. The unit of this charge, that is unit of this Q, this charge means capital Q, time means T. So this charge is represented by Coulomb. Time is represented by second. So we got one formula, that is current is equal to charge upon time. Suppose we want to calculate this charge, we can manipulate the formula. Suppose we want to find out this time, we can manipulate the formula. So depend on this formula, I have a simple problem for you. Okay, let us solve that. In your book, one problem is given, that is in page number 33. In page number 33, one problem is given. We will solve this example, which is given in your textbook, page number 33. What is that? A current of 0.4 ampere flows through a conductor for 5 minutes. How much charge would have passed through the conductor? Just now I told you that a current of 0.4 means, that means problem. What is given? Given is a current, that is 0.4 ampere is given. How much time? It get the time, that is 5 minutes. It is given in minute. You have to convert it into second. So how to convert? Multiply by 60. We have to multiply by 60 because 60 second is equal to 1 minute. So it becomes 300 second. Now what is question? How much charge would have passed through the conductor? This means we have to calculate the charge, and charge is represented by capital Q. We have seen one formula, that is I is equal to Q upon T. Here we have to find out the Q. So our formula becomes Q is equal to I into T. What is the value of I? It is 0.4 ampere. What is T? It is 300 second. So our answer comes after multiplication, it becomes 120. And because it is charge and our unit is C, that is coulomb. So our answer is, how much charge means 120 coulomb charge is passed through the conductor. I think you understood this problem, not only for 9th class but also this problem as well as all these concepts are important for 10th class students also. Okay, thank you students.